This is an introductory video to the equipment for MIE313. It's basically the standard apparatus for both the practical and the design project. So the main apparatus consists of a circuit board which is connected to a copper plate, which is then placed above several layers of insulation, and this can be easily connected to the main board by using standard Allen keys screws. So the heat source provided in this experiment are from these aluminum blocks, which consists of a resistance heater with a maximum output of 10 watts and reduces depending on the voltage input. In between the blocks in the heater are thermal resistive pads to reduce the contact resistance. Now, before using any of these heater sources, you should always double check that they're working, and to do that you can measure the resistance of the heater. For a working heater, you will register a resistance of around 70 to 100 ohms, which is correct. Now for a broken heater, you will register a very large resistance, which indicates that the heater is broken. So you will notice on the bottom of every chip there are two holes. These holes align directly with the holes placed on the board, and this is how you attach your chip to your board. The power provided to the chips is given by this following terminal strip, which is connected to 24 volts DC, which is used through this power source. Basically turn it on and directly connect the following terminal ends to the terminal strip. It's always good to check that your board is working correctly by using the voltmeter and registering 24 volts on the voltmeter. So to measure the temperature of your chips, we're going to be using thermocouples. Thermocouples consist of two wires connected at the tip by a junction. It's always correct to double check that there is a junction. The thermocouple connects to a digital thermometer through the connector end. Always make sure that you're connecting it to the digital thermometer correctly. There is one wider pin than the other. So the digital thermometer has a precision of 1 decimal point, which you can use here, which will give you a more accurate temperature reading. So to measure the actual temperature of the chip, we will attach a thermocouple using the following washer and screw. Make sure to gently tighten the screw to avoid breaking the junction at the tip of the thermocouple. Alright, so to measure the surface temperature of the board, we'll be using these surface temperature probes with the junction at the tip. And again, it's the same process. You connect the probe to the thermometer and you basically touch the board, holding the probe in place to measure a temperature value. So these are the following heat sinks that you'll be using in the lab. To fix it to the chip, it's basically the same process. You will take the heatsink and using the washer and the screw, connect it to the chip. You should also make sure that the bottom of the heatsink has a thermal resistive pad in order to reduce the contact resistance. You may also be required to use a fan in the following labs. Using this adjustable arm, you can position the fan to the appropriate position above the chip. To power the fan, you will connect the positive, which is the red wire, and the negative, which is the blue wire, to the terminal strip.